Hello everyone, my name is Güney Doğan from the Department of Civil Engineering at Middle East Technical University in Ankara, Turkey. Now I would like to present you our work prepared with my professor Ahmet Yalciner, which is the recent experiences using new tools and real-time data sharing in post-tsunami field surveys. I would like to begin with a small definition of the tsunami, which is a series of ocean waves with extremely long wavelength and long period generated in a body of water by an impulsive disturbance that displaces the water. And the generation mechanism can be seen in these small animations here. And after the generation, the large waves begin moving through the ocean, and we can say that the tsunami's journey have begun. Well, the characteristics of tsunami waves are quite different from the other ocean waves, like wind waves or other short period waves. As a tsunami has a very long wavelength, it will lose little energy as it propagates. Hence, in very deep water, a tsunami will travel at really high speeds and travel great transoceanic distances with limited energy loss, as you can see also in this animation. The tsunami slowed as it reached the shallow water towards the coast, but increased in height. The impacts of a tsunami may be devastating. The tsunamis drag the whole structures or their units at land or vessels in the sea and cause damage. An example is given here from the 2004 tsunami in Malibu. Tsunamis also cause deposition with accumulated shoreline debris by the advancing wave fronts and make the coastal facilities unusable. They also undercut foundations and pilings with erosion caused by the receding waves, and they overturn structures by suction of receding or thrust of advancing waves. There are also other impacts of tsunamis, and the resulting currents, especially in ports and harbors or headland structures, can be very damaging. So why are post-tsunami field surveys are important and necessary? Well, we obtain a lot of data from these surveys to understand and describe the event and the regional effects, especially in terms of the impact or damage to both the natural and the built environment. We document the tsunami parameters such as the water levels, the arrival time of the waves, and the inundation extent. We describe the reducing or increasing factors of the impacts, and we also evaluate the human behavior and awareness level. And all these efforts actually contribute to the preparedness and resilience against tsunami hazard. So how do we perform these field surveys? Indeed, we have a post-tsunami field survey guide presented by the UNESCO Intergovernmental Oceanographic Commission in 2014 as a second edition. In this guide, the conventional methods to perform a post-event survey are described with the terminology of the parameters shown in this slide. The main parameters are the tsunami run-up, the wave height or tsunami height, flow depth, current velocity, the inundation distance, and the maximum rundown or maximum negative wave amplitude. Well, we have these conventional methods on one side, but with the developing technology, we have very useful new tools which make the things easier. Like we can cover larger areas in shorter time periods, and we can perform more measurements in this way. I want to share our recent experiences on the post-tsunami field surveys, starting with the 2018 Indonesia tsunami, which highly impacted the coastal areas in Palu Bay in Sulawesi Islands. This event unfortunately resulted in many casualties, and about 1 month after the event, we were in the area as the UNESCO International Post-Tsunami Survey team, following Professor Yalciner as our leader. We performed run-apide, flow depth, and inundation distance measurements along the coast of Palu Bay, as you can see in these figures, with some additional work, such as GPS tracking for shoreline comparison before and after the event, bathymetry measurements on a boat at Donggala port, and we also did real-time data sharing from the site with the people in other locations. Here you see an example of GPS tracking of the coastal collapse areas, which were very common in this event. And the mapping of these GPS tracking results for the coastal collapse areas for Benteng region is shown here on Google Earth. And it provides us a good comparison before and after the event. And those are the bathymetry measurements you see on the right hand side. These were our measurement points at Donggala port, and you also see a panoramic view of the coastal damage in one region, showing us the overall impact actually in the area. This slide is showing the application that we used during our survey, which was developed by European Commission Joint Research Center, FRT, the field report tool. Which enabled us to share our data simultaneously with the other experts in the other parts of the world. And these remote contributors provided us feedbacks and actually contributed to the survey remotely but very actively. Now I'm moving on the most recent tsunami in the Aegean Sea, which occurred on 30 October and affected the Turkish coastline in Izmir and the Samos Island coastline in Greece. I would like to highlight the importance of fast tsunami numerical modeling, which helps us to show the overall tsunami inundation zones, and so that we can focus on during our post-event survey. We experienced that the security video recordings are very important, especially if no measurement is available in the near field area. So one can extract the timing of the waves and the water level changes from such records, and this is an example for the 30 October Aegean Sea tsunami in Alaçatı, Izmir region, and it provided us very good data. Mapping and GIS tools also helped a lot to us in the survey. Here's an example of showing the overall inundation zone in Zeytinli region, which was about 760 meters in the area with a maximum tsunami height of 2.4 meters. Here I would like to emphasize the contribution of drones to the impact assessment actually after tsunamis or maybe in other hazards. As you can see, the drone image taken in Sığacık Teos Marina, which was one of the most impacted areas. The image on the right clearly shows the damage and provides very valuable boat damage data. And an interdisciplinary teamwork is also very valuable for a successful fieldwork actually, as experts from different disciplines such as engineers, social scientists, and administrative people are key partners that we need. Everyone needs each other actually for a successful field work, for a comprehensive evaluation of the event. Eyewitness interviews are also as important as measurements, as those people were there experiencing all that happened. We are just in the area after the event, but they were there, so they must show us and describe the impacts and provide valuable information of the water motion and of the impacts in their area. So in summary, I want to emphasize the importance of map tools in mobile phones, which are very helpful, GPS tools, which provide high precision measurements, The importance of social media, which provides fresh data from the impacted areas and guides the survey teams before the field surveys to determine the survey areas. And also numerical modeling and visualization of the tsunami coastal amplification to provide a general picture. The real-time data sharing at all stages of the field surveys, and developing technology helps data collection more effectively, much more data at a specific survey period. And maybe one of the most important things, the coordination of survey team members is very easy now via such messaging applications like WhatsApp or any other. It makes the things really easier and faster. Many thanks.